let's do the daily. You're given two integers m and n represented a0 and xm by grid. You're also given two integers, guards, walls, represents the position of ith guard and jth wall respectively. A guard can be seen in every cell and for Cardinal, maybe DFS. Starting from their positions only obfuscated by a wall or another guard. Okay, I see. A cell is guarded if there is at least one guard that can see it. That's not guarded. Okay. Okay. I want to say DFS, but I feel like it's just like simulation, no? We could just like okay, create a. We're not given it. Yeah, we're just given the dimensions. We're given the thing and just fill it up. Just fill it up, I guess. So fill up the guards, the positions that the guards take, fill up the positions of the wall, and then fill up the positions that the guards can see, and then count that or not any of those. Yeah. I don't think we need to do like. Yeah, I don't see a DFS. DFS seems a little bit complicated. Okay, so we're gonna have to mark it. Okay, so let's do this. Let's use numbers. So say 0 is unguarded or free. 1 is wall. 2 is guarded. 3 is guardable. Yeah. Because guard and the red is a little different. There's 1, 2, 3, 4. So yeah. So for the start, of course, times how many rows? There's 4 rows, so we'll do n for range of m. Print grid. Yeah, let's try that really quick. That is 6. Yep. Yeah. They're about n. Yeah. Okay. Yeah, that is the correct amount of. That's our correct dimensions. Okay. All right. What do I do now? We're given the position. What is the coordinates? Okay, perfect. Let's just mark. Okay, so for every row, call in guards. For every guards, grid RC is equal to 2. And then let's do it again for walls. Wall is 1. And then let me just see the output of that grid. Let me see. Let me see this visually. Does that make sense? Guard, wall, unoccupied. And then of course, yeah. Perfect. This looks like yeah, exactly like it. Perfect. So that's exactly what we want. Pretty straightforward. Now the hard part is, basically, hold on. It's the result, I guess, count is just this. For every row in grid, for every for every val in row, if v equals 0, count sound equals return count. Right? Okay, that's basically the algorithm, except I haven't considered the guardable, like the red. I don't know how to do that. Let's see. Basically, okay, I see now. Maybe go through every single. No. We don't even need to go through the grid. I could just go through the guards. So for every RC in guards, okay, what do I do here? Go down. So let's see, this is the first one, right? One coordinate is 0, 0, right? There, I just need to okay, I see. So source, we'll call this RC, right? We don't even need that. Okay, so we know. Okay, so what is it? Northeast, southwest. So let's start going. I guess no. Let's try going up. Only up. So okay, which is decrement R. I might need to make this a function actually. Like, okay, yeah. Mark guard. Damn, I don't know what to do. Okay, since I need access to this variable, I'm gonna make a helper function. Mark guard. We take in RC, I guess, and then we need to do I guess I could do like a while R. Okay, yeah, I need to like. I'm gonna make row call equal to row RC because I want to like temporarily. I don't want to alter them. So I want to do. So first is up. So let's do up. Let's do row. So that means we just need a decrement R. So while row is greater than 0. Right? Row decrement. First check if grid of row call is equal to I got it. So when do okay, we want to break out if we're out of bounds. First we won't even be there if we're out of bounds. What was the condition? Obstructed by obstructed by wall or another guard. So if there's another guard, so if it's basically a 1 or 0, no, 1 or 2. If it's say 1 or 2 in. Okay, we could do in, or let's do it equals 1 or grid of row call equals 2. If that, yeah, then break out. Otherwise, we can set grid of row call equals 2 or 3. 3 is guardable, right? Yeah. Okay, that's up. Probably like very similar logic. So this one there's not gonna, it's gonna case, right? Let's do right. That means we just move call. Damn, I have to reset row call. Yeah, reset. And then just this one is make sure you're less than length of grid of 0. Alright, so we could just say while we're less than n. We could say row column equals 1 and then this time we move to the right, so call. Okay, now this is up, down, no, up, left. Let's do down now. Yeah, up, down, up. So up, down, left, up, down. Okay, up. No, that's not left. What am I saying? This is right. Up, right. Down. Down is just increasing R. So I want to make sure I am row less than M. And then I want to increase row. Yep. And then do it again. This is left now. Let's do this here. Oops. Left should be controlling column. Right? Controlling column. Make sure this is positive, because I can be, yeah. And of course we want to control the column. We want to go left, so we do it this way. Yeah. Mark guard. Okay, yeah. This is gonna be a side effecty function, so I don't need to return anything. Mark guard. Row C. Yeah. Doesn't even make sense. Hold on. Row is greater than equal to that. Yeah. Oh my god, sorry. Let's be consistent here. For walls, guards, for every guard. Yep. Alright. Okay, of course I'm. Oh my god. Alright, that sucks. If it's equal to 0. Let's see. Wait, is 3 the right one? If it's equal to 2, 1 or 2. Hold on, let me just make sure hold on, let me see the print. Let me see this like the resulting grid. I feel like I'm overriding like stuff right now because I don't know if this is resetting. Oh, looks reasonable. 2, 1. Ah, that's the problem. We're not actually altering anything. How about I'll just make this, hold on, I'll do this self-dot. Grid, self-dot, grid. Yeah. How about that now? Yeah. Runtime error, what? Uh-oh. Oh my god, what is happening? This is why I hate LeetCode, bro. They don't have a find replace all. I don't know why this didn't get why this one wasn't checked for. Of course this one doesn't. It's breaking. I prefer the object preferred way. Uh-oh, did something break? More wrong answer. We got 18 still. I don't know why. For row in self-guard for value in row, for if v equals, then count that, then. Yeah. Okay, one thing I need to make sure is the row column being reset. So let me see. Print. Let me make sure. Me print RC, and then let's also. Okay, I'm not sure actually. So first print here, print RC that it's also being altered. Print RC here, so it's not. It should stay the same. 0 0 0 0. Yep, 1 1 1. Okay, so they're just staying the same. Okay, so they're not being altered. Okay, good. Oh, I see why. Cause I know why now. I should probably okay. Let me start off with an adjustment first because this is already a guard, so it's gonna mark it. It's gonna exit the while loop immediately. So first is up. So up should be a -1 to row. So I'm gonna do -1. Then the right is going to be a +1 to call. So we'll start off with a +1 to call, right? Same thing with so down is also a +1 to the row. Oh yeah, that makes sense. And a left is a -1 to call because we're going left. All right, that makes complete sense now because we already are starting off with always only checking for guards, and then there's a break statement here that just breaks out as soon as you find a guard, and obviously it doesn't make sense to mark yourself. Please work. Should work, I think. Yeah, very nice. All right, see you guys tomorrow.